Here for my second lesson for you guys. We talked last week about the law of sines. Now we're going to talk about the other way to solve non-right triangles, and that is the law of cosines. This one isn't quite as user-friendly. Law of sines is pretty straightforward because once you get the ratio set up, it's just cross multiplication. With law of cosines, it actually mirrors, it's a little bit more related to the Pythagorean theorem, and also related a little bit to the distance formula of way back when. So you're going to see a lot of squares, and then you're also going to see cosine in there. That's why it's called law of cosines. So there are three separate little formulas, and just like before, you don't have to use all three at once. You actually only use one at a time, and it's all based off of the information that you know. So the big thing to know when you have to use law of cosines versus law of sines is if you don't have that matching pair, like in law of sines, where you don't have a matching side and a matching angle, then you're going to have to use law of cosines. Now, just like before, we're going to solve for all the different sides and angles that we're missing, but you don't necessarily have to use law of cosines the entire time, and I'll show that in my examples. Usually if you don't have a matching side and angle like you need for law of sines, you can use law of cosines to help get you that matching pair, and you can also switch back to law of sines if you like. Like I said, that's typically how I do it, and that's what you're going to see in my examples. If you want to use law of cosines for the missing parts, you certainly can. But like I said, once I use law of cosines once, I'm going to switch back and use law of sines again. The other thing is, just like before, once you have two angles, you can use the 180 rule to find the third. So let's get started. So I'm going to show you one at a time. So this one is set up to find side A. So again, lowercase letters are still sides, uppercase letters are angles. And so if the way this is set up to use right away is if you happen to know side B, side C, and angle A, this is set up ready for you to use to plug in. Now every once in a while you'll have all three sides and you're missing an angle. So sometimes the angle is what's left blank, but a lot of times if you're going to use this, you're either looking for angle A or side A. So what you really need for sure is the two sides B and C, and that gets used twice. Here they are squared, so you have B squared, C squared, and then addition in between it. And then here it's 2 times B times C times cosine. So this is all being multiplied together. So make sure you watch that when you're doing order of operations, because sometimes you'll want to subtract this number first before you multiply cosine. But again, order of operations, you need to multiply this whole thing out. And then A is over here squared. So like I said, when we use this first formula, as if either looking for side A or angle A. That's what it's set up, okay? Because each formula only uses one angle. So if you're trying to find angle A, you have to use this one, okay? Also, if you know sides B and C, then you can find side A. So then the second one, same type of information, only switched around a little bit. This is set up to find either side B or angle B. So again, you need the two sides. You have to know these, or both of these in order to use this. And then you can either know angle B or side B in order to use the second one. And then the third one, again, the same idea, only it's set up to find C. So again, it's just rearrangement a little bit. So the sides are kind of interchangeable. So if the letters aren't A, B, and C, you can switch there out. But again, if whatever side you're looking for, you know, two sides and an angle, so just plug it into the corresponding spots here. Or if you know all three sides, you can put it in for the sides part of the formula and look for that one angle. So I'll go ahead and show you the third one. Again, we only use one at a time, depending on which angle and side we're looking for. So the first one's set up to find either side A or angle A. Second one's set up to solve for either side B or angle B. And the third one is set up to find side C or angle C. Okay. So I'll give you a little bit of time to look at those. There are two main situations where you have to use law of cosines, and that's if you have all three sides. So we're going to do an example of that, because when you have all three sides, there is a spot on each one of these formulas to put all three sides, so you can use law of cosines. And then the other one is if you have two sides and an angle, but those sides and angles do not match, okay? Because I know I gave you a couple of questions where you had more sides than angles, but you're still able to use law of sines. As long as you don't have a matching pair, you have to use law of cosines. We're going to do two examples. Like I said, there's two main examples. When you have all three sides, or when you have two sides and an angle, but the angle and the side don't match. So the first example we're going to use, it has all three sides. So again, most of the triangles will be drawn for you. If they're not, do it and go ahead and sketch those out so you can get a visual of it. So let's see, my longest side looks like this. So that's what I'm going to label with my 19. So that makes this angle B. My shortest side is over here. So I'm going to label that with 8. That's my angle A. Okay. And then this one is slightly shorter, so it's 14. And that's angle C. Okay. So I know all three sides. Again, I don't have the requirements for law of sines because I don't have a matching side and angle. So I'm going to use these three sides to find any one of those angles. It doesn't matter which one. I typically like to pick the bigger angle to find first. Everything just seems to work out a little bit better when I do that. So the bigger angle will be correspondent with the bigger side. So what I'm going to find first is angle B. Okay. So I'm going to set it up so that B, the capital B, is my variable, the one that's missing. So I'm going to use that second formula and plug in what I know. So I know A, side B, side C. And so what I'm setting it up is to find that biggest angle, angle B. Okay. And I just picked that one. You could find angle A or angle C first. It's just kind of your choice, but I like to pick and find the bigger angle first. Okay, so the way that's set up, I'll go ahead and rewrite it on this slide since I don't have it here. It's B squared, and then equals A squared plus C squared minus 2 times A times C, and then cosine of angle B. Okay. So the order kind of works out the same way. So whatever angle and side you're finding, those are your endpoints. So B squared equals, and then the very end is cosine of B. And then in between that is the other two sides squared. So A squared plus C squared, and then it's minus 2 times both those sides. So that's kind of how I can figure out the pattern. Again, don't feel like I have to memorize it. I'm just giving you some tricks. You can always write those down. So this is to help us find angle B. So I'm going to plug in what I know. So side B is 19, so we're going to 19 squared, and that equals A squared, so 8 squared plus 14 squared, then minus 2 times 8 times 14, and then times cosine of angle B, which I don't know, so I'm going to leave as a capital B. So I always do a couple of preliminary solving things before I go ahead and rearrange this equation. So I'm going to go ahead and square everything out. I don't know what 19 squared is off the top of my head. So I'm going to do 361 for that. 8 squared is 64, 14 squared is 196. I'm going to go ahead and multiply these three numbers together, the 2A and 8 and 14. So got 224. And that's still attached to cosine of B. So like I said, I think a couple of preliminary things to solve that out. So you have squared everything, and then you can multiply the 2, 8, and 14 together. Okay, now we're to solving an equation, and our equation here is a little bit weird because the variable that we're solving for is that angle B that's there. So we need to move everything away from it. So I'm going to start from the very furthest thing away from it. So that's 64 and 196 I'm going to move. And you can add those together and move it together. I'm going to add it or subtract them separately. Just so that, because there's some common mistakes that happen. You can add these two together, 64 and 196, but we cannot subtract it with this number. Why we can't subtract it with this number is, like I said, because it's being multiplied by that cosine. Order of operations tells us to do this multiplication first before we can subtract, okay? So that's why I usually do it in a couple of steps so I don't confuse it and accidentally move things around that I'm not supposed to at the same, or add and subtract things I'm not supposed to yet. Okay, you could, like I said, you could add these two together if you want, because it is separate from that multiplication, but you cannot subtract it with the 224. It's not going to work. Most of the time you're going to get an error if you do that. So I'm just going to do this in a couple steps. So I'm going to subtract the 64 first. I take 361 minus 64. So I got 297. So I subtracted 64. Now I'm going to subtract the 196. So we got 101. Okay, make sure you don't lose the negative. Okay, so that negative is still going to be with 224. So now my next step is, again, I'm trying to get the b by itself. So first thing I have to do is get the cosine by itself. So I subtracted these two things that were being added. So I subtracted 64, then I subtracted 196. So now what I need to do to get rid of the negative 224 is I need to divide. Okay, now like I said, don't lose track of the negative because when I divide that over, that's going to make this number negative. Now you will get a kind of a tiny decimal, and that's okay, and I'll explain a little bit more here in a second. So I get rid of that. I'm going to move over here. And it's okay to, like I said, combine some steps so it doesn't look quite so long. And you don't have to rewrite the formula each time. So I'm just trying to make sure I really go step by step since we're not all together and you're just watching me on YouTube. Okay, so we're going to divide by negative 224. And like I said, you're going to get a very little decimal here, and then it's going to be also negative. So don't lose track of your negatives as you're going through this process. I'm going to write down quite a few decimal points on that because the more you have, the more accurate you'll be. So typically I do 4 because that's going to get you a little more accurate on this next step. Okay, so now I've got it down to that little tiny decimal equals cosine of b. Okay, so does anyone remember what you have to use when you're solving for angles? You're actually going to end up having to do cosine inverse to figure out what b equals. So b is going to equal cosine inverse, and then just put this tiny decimal. Make sure you keep that negative. So we're going to use cosine inverse to solve for that angle. So you got negative 0.04509. Type something wrong just a second. So I got 116.8. So once you get to this step, the way we find angles using trigonometry is using cosine. So once you have it to this step, if you just take cosine inverse of this little tiny decimal, that'll get you that angle. I rounded it to the nearest tenth. I think sometimes I have rounded to the nearest whole number. So if you want to round that up to 117, I'm fine with that. But usually tenth or whole is good on this. So that's this angle. So I'll give you a second to look at that. I'll probably talk a little bit while I'm doing it. Again, you can combine some of those steps. This is what I was talking about with lost cosines not being quite so user-friendly, especially when you're trying to solve for an angle, because there is a little bit of steps to it. But again, as long as you keep track of all your signs, don't lose any numbers, you should be good to go. Okay. And then whenever you're trying to find an angle, you'll have to use inverse. And there's a couple like that on Wednesday's worksheet from last week. So we had to use sine inverse to find an angle. So if you have to find an angle, use whatever trig function inverse. So it's going to be second cosine for that. Oh wait, so you could repeat that entire process for finding A or C. So we just flip around some numbers. Or now what I notice is that I have that matching side and angle, so I can switch and use law of sines. And that's what I'm going to show now. Okay, and it doesn't matter which angle you find next. Let's go ahead and go in order. So we found the biggest. I'm going to find the next biggest, which would be C. Okay, so like I said, I had to use law of cosines to start with because I didn't have that matching side and angle pair like I need to use with law of sines. So that's what the first steps were showing. And again, I did it really step by step so you can see where all the numbers are coming from. I talked a little bit about how you can simplify some of those things and combine some steps. But now that I have a matching side and angle, I'm going to switch back and use law of sines, which is a little more user friendly. So I'm going to cross multiply. So I got 14 times the sine of 116.8, and that equals 19 times the sine of C. Okay. So it's a little bit different because we're finding an angle. Like I said, I put one of these on your worksheet on Wednesday. So we're going to do 14 times sine of 116, and I'm going to divide that by 19. Oh, this is a mess. I only myself enough word space, so I'm going to try to squeeze it in here. Okay, so I'm going to do 14 times the sine of 116.8, which is 12.49. Divide that by 19. Again, you're going to get a small decimal again. Whenever it's sine of angle or cosine of an angle equals something, it's going to be a tiny decimal. So I'm going to do 4 decimal places for this. 0.6577. And that's going to equal my sine of C. And again, in order to solve for an angle, I'm going to have to use sine inverse. I'm going to put that little number in there. That'll give me C. Yeah, 0.6577. So angle C is going to be 41.1. And now that I find those two angles, like I said, if you really want to, you can use law of sines or law of cosines to find the next one. But now that I know 2 of the angles, to find that third angle, I'm going to use a little bit of subtraction. So I'm going to take 180 minus 116.8 minus 41.1. And so angle A is 22.1 degrees. So there's the first example. So at first I found angle B using law of cosines. Second, I found angle C using law of sines. And then third, I found angle A. So again, once you know those 2 angles, you can find the third angle with a little bit of subtraction. So you have a couple where you have all 3 sides. So all 3 sides will follow a similar trend with this one. Again, combine some steps if you need. But that's what we'll need to do for problems like this. So you'll need to find all 3 angles. Now the next example we do is going to be a little bit different. I'm actually going to have an angle, but it's not going to be a pair. So we're going to have to find find a side using law of sines, or sorry, law of cosines. Finding a side is a little bit easier, in my opinion, just because with this one, the variable is over here with a bunch of stuff, so we had to move stuff away from it. The way these are set up really nice to solve are sides, because the side is already by itself over here. So we'll have everything over here, and we'll just need to find a side. So that's what we're going to see in the next example. So this is my biggest angle, so I'm going to give that 115. That's angle A, so side A would be across from it. Let's see. Those two are pretty similar. This was a little shorter, so I'm going to put my 10 centimeters here. And so this would be angle C, and then my 15 over here. And so that's angle B. Okay. And again, I'm not super worried about scales, but again, I do like to visualize the triangle so I can see it. Okay? So again, I don't have enough information to use law of sines, because again, I have this angle, but I don't know its side, and I don't know enough to find either one of these angles. Because again, if I found one of the angles, I would have a matching side, but I need two of them in order to find it using the 180 degrees trick. Now, if I found this side that's across from the angle I do know, I could use law of sines. So that's the thing I'm going to focus on first, is finding this side. Because once I find angle A, or side A, it matches the angle that I have, and I can switch and use law of sines. Okay, so the formula that has little a, where I know capital A, is that first one that's listed. A squared equals B squared plus C squared minus 2 times B times C, and then times cosine of angle A. Now this one I don't really have as much choice because I only know the one angle, and the angle only shows up once per formula. So since I know angle A, I have to use that first one that's listed. So I know all of these things. I know b, little c for those spots, and I know big A. The only thing I don't know from this part of the formula is this little a squared. Okay, so like I said, it's set up a little bit more user-friendly this way when you're finding a side versus an angle. So let's go ahead and work through it. So I'm going to leave little a blank. I don't know what that is. So then I have b squared. So b is 15 squared plus c squared, which is 10, minus 2 times 15 times 10. And then times, and I actually know the angle, so I'm going to plug in my 115 degrees into cosine. So like I said, that's what's a little bit different here, is I actually know that angle. So I actually know everything on this side. So that's why I like this type of a problem a little bit better with law of cosines, because all I have to do is solve this whole thing out, and then to find A, I just have to, don't forget to square root, okay? If you're getting sides that are huge, that just means you forgot to square root. So I'm going to solve this whole thing out, and you should be able to, after you do a little bit of a preliminary simplification, should be able to type it in at once if you're using a regular calculator. If you're using a phone calculator, it'd still be a little bit leery on that, but yeah, just make sure you're careful. So we got 15 squared. I'm going to go ahead and solve that out. That's 225. 10 squared is 100. And take 2 times 15, which is 30, times 10, which is 300. And then times cosine of 115. You could add these together, make that 325 if you want, but you cannot subtract the 300 yet, because 300 needs to be multiplied by cosine of 15. 115, sorry, I said 15. So now, what you could do, and what I'm going to show, I'm going to actually go ahead and multiply that out. It's going to be kind of a weird number, I'm going to take 300 times cosine of 115. Now this is where you're going to have to be really careful. When I did that, I'm going to show you my calculator. I just typed 300 times cosine of 115, and I got a negative answer. But there's already a negative there, so I might have to keep both negatives when I write it out, because when you have two negatives, it's going to make a positive. So that's where you have to really kind of have to watch your signs. So I'm going to go ahead and add these together, like I said. So you can make that 325. And it'll be minus a negative. And I took 300 times cosine of 115. So I got negative 126.7854. So like I said, when I typed this part in, I got a negative, and there was also a negative there. So you have to be really, really careful with that, because you shouldn't get negative answers necessarily here. So again, when we have the two negatives, we have to add this together. So I'm going to take 300, or 325, whoops, plus 126.7854. Again, I just do more decimal here, because then because you're kind of rounding in the middle, so you'll get a little bit more accurate answer if you do a few more decimal places in the middle. Okay. So yeah, the nice thing is you don't have to worry about moving stuff around. You just have to make sure you solve it out. And like I said, if you have a regular calculator, you should be able to type this in all at once. 225 plus 100 minus 300 times cosine of 115, because the regular calculators are programmed nicely for you to for it to do the order of operations for you. If you're on a phone calculator, just be a little bit careful as you're going through it. Okay. So this isn't quite my answer. This is what a squared equals. So the way we get just a, how do we get rid of squares? We have to square root it. I'm going to take the square root of 451.7854. So we get 21.25. So I'm going to 21.2 centimeters. So there's a little line. Okay. And as you can see, and I did this one step by step as well. This one doesn't take quite as much work to get to that. You just have to remember a couple things. Keep track of all your signs here in the middle. Don't forget to square it at the end. So I got 21.2. If you got slightly different, if you rounded a little bit different, or if you typed it all in at once, you might have gotten a little bit different round. But again, as long as you're close, you should be fine. Okay. And now I have a matching side and angle. And so I'm actually going to switch and use law of sines again. Feel free to use law of cosines again if you'd like to find the two angles that we're missing, but I'm going to switch and use law of sines. So I know sine of 115, and now I know that side of A, which is 21.2. And then it doesn't matter which one we find next, so I'll go to the next biggest one, which will be angle B. Again, since we're finding an angle, we will have to end up using an inverse to do that. So we'll have to use inverse sine here in a little bit. But I'm going to do my cross multiplication now. So I got 15 times sine of 115. And that equals 21.2 sine of B. Okay. Divide the 21.2. So I got 15 times sine of 115, which is 13.59. Divide that by 21.2. So I got 0.06464123. I'll round to 3. Okay. And again, to solve for an angle, use inverse. Have a little more room to write on this example. So again, find angle. Once you get to this point, if I do sine inverse of 0.6413. That'll give me angle B. So that gives me 39.88. I'm just gonna round to 40, okay? Because again, when I got it, that's what I got on my calculator. But I'm gonna round it to 40. It's close. 39.88, 39.9 or 40 is about the same. Okay, so there's my second piece of information. So again, first I found side A, then I could switch and second find angle B, okay? And then third I need to find angle C, which I can use a little bit of subtraction. 180 minus 115 minus 40, and that'll get me angle C. So I have 25. And it all should make sense because all sides kind of are similar to angles. So the biggest side should have the biggest angle. The next biggest side should have the next biggest angle. The smallest side should have the smallest angle. So you have a little bit of time to work on that or look at that. All right. Well, like I said, I showed you an example of each. Hopefully that's enough. Again, if you have any questions, email me. Or I'm gonna do a Google Hangout video chat on Mondays and Wednesdays from 11:30 to noon is when I have it set up. So that way, if you need a video conference with me, click the link that I put on Classroom. You can upload that. But again, if you have any questions, please let me know. There'll be a little assignment attached to this as well. So, bye.